In this session, we are going to study something related to this Cambridge IGCSE Mathematics Core and Extended Course Book, third edition. And we are going to start exercise 1.1 in this. It is a set of numbers, and we need to list the numbers from this set that are natural numbers. So natural numbers is the set that starts from 1, 2, 3. That means positive whole number, positive integers, those constitute the set of natural numbers. So for part A, we can have the answer would be this won't be the case, this won't be there because it's these two are negative. This won't be there because set of natural numbers starts from 1. This is a fraction. This is also a decimal number. So the natural numbers are these. So you can write down 3, 4, 6, 11, 16, 19. So that's the answer to part A. Then in part B, you need to give the answer of the even numbers. When you talk about the even numbers, so we can have -4 there because -4 is an even number because you can write down -4 as a multiple of 2. 2 times -2. So since it is a multiple of 2, that's why it is even. So that's what we have written in the set of even numbers. Then 0 is also even because we can write down 2 times 0 as 0. Then 4 is an even number. 6 is an even number. 16 is an even. So this is part B. Now for part C, the odd numbers. -1 is an odd number. Then 3 is an odd number. 11, 19, and 25. These all are odd numbers because we define odd numbers that whenever you divide an odd number by 2, you get 1 as the remainder. Like you divide 3 by 2, 2 ones are 2, you get 1 as the remainder. You divide 11 by 2, you get 1 as the remainder. You divide 25 by 2, you will get 1 as the remainder. So that's why these all are odd numbers. So like unlike this even numbers, if for example you see you divide 16 by 2, 8s are 16, remainder is 0. That means the number which are completely divisible by 2 or a number which is divisible by 2 in such a way like completely divisible, or you can say that when you divide a number by 2 and the remainder is 0, the number is an even. So with this, it is now part D. You need to segregate integers now. The integers. Integers means whole numbers, whether these are positive or negative. That makes no difference. -4, -1, 0, 3, 4, 6, 11, 16, 19, 25. These all are the integers. Okay. Then in part E, you just need to segregate the negative integers only. So the negative integers from these are -4 and -1 only. Then with part F for fractions, you can see that the fractions are 1 by 2 and 0.75. That is also a fraction because we can write down 0.75 as, if you eliminate its decimal, that would be 75 divided by 100. So simplifying them and cancelling on the table of 25, 25, 3s are is 75 and 4s are is 100. So 3 by 4 is an equivalent fraction of 0.75. So that's why we have included it in the set of fractions. Okay. Uh, though I need to clarify another concept over here. That is, every integer in this case can be expressed as a fraction. Like for 25, we can write it down as 25 by 1. 19 can be written as 19 by 1, and so on. In that sense, all of these uh, integers are or can be treated as fractions of. But out of the given set of numbers, these two are which can directly be regarded as the fractions. Okay. Then I proceed to part G, that is square numbers. Square numbers are those numbers uh, which are perfect squares, like you multiply an integer with itself to get that number. One thing. Secondly, the second definition is that a perfect square is a number whose square root will be a whole number. Let me clarify it in both the cases. Like 1, 2, 3, 6, 7. I'm calling one square. That is 1. So that 1 is a square number or a perfect square. Then for 2, if you do its 2 square, that would be 4. So 4 is a perfect square or a square number. Same goes for 3. 3 square, that will give us 9. 4 square, that will give us 16, and so on. And if you just apply the second definition, that is, if you take the square root of 16, you will get, if you take its positive square root, you will get a positive whole number or a positive integer, positive whole number. Similarly, square root of 9 will give us 3. Positive square root of 4 will give us a whole number 2. And positive square root of 1 will give us a whole number 1. So 4, 3, 2, 1. These all are whole numbers. So that's why you can see. Now for this concept, let's apply this to part G. Square numbers out of these are 0. If you need to start 0, you can write it down. 0 square, that is 0 times 0. That is 0. So that may be regarded as a square number. Then what about 1? 1 is not there. So we can regard 4. 4 is a square number. Then 16 is a square number. And then 25 is a square. We do not regard 0 as a square number, because in that sense 0 could also be written as a cube number as well, because 0 cube is 0 times 0 times 0. That is 0. So it might be regarded as a cube number as well. It might be regarded as a square number. So some conventions are like we need to include 0 and some are to exclude it. So it might be, in this case, we can consider it only 4, 16 and 25. We might not consider it 0 as a square number. So this is the answer to part G. Then part H, prime numbers. Prime numbers are those numbers which have got two divisibles, the number itself and 1. Okay, one thing I need to include here, why we haven't regarded -4 as a square number. Because if you multiply -2 with itself, you will get +4. That is not equal to -4. Or if you just multiply 2 with 2, you will get +4. Again, that is obviously not equal to -4. So there is no whole number which is being multiplied with itself to give you -4. So that is why -4 is not regarded as a square number. Okay, then for the prime numbers, part H, a set of prime numbers starts from 2. That is, and so on. So in the given set, we have got 3 as a prime number, 4 is not a prime number, it is known as a composite number because it has more than 2 divisors. It has got a divisor 4 itself, then 1 itself, 1, and then 2 is another divisor of it. So 2 is a 4 is a composite number, not a prime number. Same goes for 6. 6 is a composite number, not a prime number, but 11 is a prime number, and 19 is a prime. And then for part I, neither square nor prime. A number which may not be a square number, nor should it be a prime number. -4, it's neither a square number nor a prime. -1, neither square nor prime. 0, neither square nor prime. 1 by 2, 0.7. Then what else? If you consider 3, that is a prime number. If you consider 4, 4 is a square number. Then you consider 6. 6 is neither a square number nor a prime. So yes, that would be included here. Then 11 is a prime number, 16 is a square number, 19 is a prime number, and 25 is a square number. So that is the answer to part I. So this is how you do this segregation. Okay, then it is question number 2. List the 4 odd numbers after 107. So the odd numbers are going to be after 107. 109, 111, 30, 115. So these are the 4 odd numbers after 107. 4 consecutive even numbers between 208 and 2030. So you need to have 4 consecutive. Consecutive numbers are those numbers which occur one after the other without any discontinuity. Like, let me give you an example. 1, 2, 3, 4, 5, 6. 1 and 2 are consecutive. 2 and 3 are consecutive. But 1 and 3 are not consecutive since 2 is there in between. One example, one thing. Then if you just are talking about consecutive evens. Then 2, with that you have got 4 as the consecutive even. And then 6, 2, 4 and 6. These are consecutive evens. But if, for example, 4 is not there, then 2 and 6 are not consecutive because there was 4 in between. So 2, 4 and 6. 4 and 6 are consecutive, or 2 and 4 are consecutive even numbers. But if you just compare 2 and 6, there is another number 4 in between. So that's why 2 and 6 are not consecutive even numbers, but 2 and 4 are. Similarly, 4 and 6 are. So now for this question, you can have either 210, 212, 14, and then 16. These are 4 consecutive even numbers after 2008, and these are obviously in between 2008 and 2030. You can have any other consecutive numbers. Like for example, you can have the consecutive number starting from 12, 2012, 14, 16, 18. These are 4 consecutive even numbers. You can also start any consecutive numbers from, let's suppose, 18, 20, 22, 24. These might also be considered. But if, let's suppose, you skip any of these, let's suppose you have skipped 2020, and then you have mentioned 2022. These are even numbers, but these are not consecutive now. So you need to fulfill both the conditions. The numbers being even as well as consecutive. Okay. Then for part C, all odd numbers between 993 and 1007. So after this is 995, then 997, then 999, then 1001, 1003, and 1000. So that's answer to part C. Then part D, the first 5 square numbers, as we were discussing previously. So part D, first 5, starting from 1, 1, 2, 3. Square of 1 is 1. Square of, this is not a ratio actually. Square of 2 is 4. Square of 3 is 9. Square of 4 is 60. Square of 5 is 25. So these are the first 5 square numbers. The first 5 numbers are 1, 2, 3, 4, 5, and their squares are these. Okay. So your answer is going to be this one. Then part E, 4 decimal fractions that are smaller than 0.5. Lesser than 0.5, you can consider like 0.4, 0.3, 0.2, 0.1, like this. So you can convert them into fractions as well. This could be 4 by 10. This could be 3 by 10. This could be 2 by 10. 1 by 10. So you can further simplify them. Obviously, this could be simplified to 2 by 5. This could be simplified to 1. So 2 by 5, 3 by 10, 1 by 5, and 1 by 10. These are the four decimal fractions which are smaller than 0.5. Okay. In the same way, we can have answer to part F, which states that four common fractions that are greater than half but smaller than 3 by 4. Okay. Let's do it as part F. Uh, Greater than half and lesser than 3 by 4. These could be 2 by 3. These could be 3 by 5. This could be 4 by 5. This could be 5 by 7. You need to see uh, the answers. Answers are the answer to this is 0.5. The answer to this is 0.75. So you can have any value in between and then you can convert it into the fraction. Like for example, we can have value of 0.6. You can have 0.65. Then you can do it as 65 by 100 and then cancelling on the table of 5. 5 ones are 5, 5 threes are 15, 5 20 are. So 13 by 20, that could be another fraction. You can also do it like this 0.6. So 6 by 10. So that would give you 2 3s are 2 5s, 3 by 5. So you can have any numbers in between and you can work accordingly. Okay. Then it is question number 3. State whether the following will be odd or even. So you can have one example each and evaluate the answer. The sum of two odd numbers. These are two odd numbers, 1 and 3. The answer is 4, which is an even number. So the answer to part A is going to be even. The sum of two even numbers. 2 plus 4, that is 6. This is even. So this is answer to part B. Then part C, the sum of an odd and an even number. 1 plus 2. That is odd. Similarly, for the square of an odd number, let's suppose 3 square, that is 9. So this is odd. For part E, the square of an even number, let's suppose 2. Square of 2 is 4. 4 is an even. Part F, an odd number multiplied by an even number. 3 times 2, that is 6, which is E. So this is how these questions are to be done. So we are done with exercise 1.1. Up till here. Okay.